Chang'e 5, a historical, present, and future perspective. Introduction. Chang'e 5 marks a significant milestone in China's lunar exploration program, representing the nation's fifth lunar mission and its first attempt to retrieve lunar samples. Launched on November 23, 2020, this mission aimed to collect and return lunar material to Earth, enhancing our understanding of the Moon's geology and history. This report delves into the historical context, the mission's achievements, and its implications for future lunar exploration. Historical context. China's Lunar Exploration Initiative, the Chang'e program, is named after the Chinese moon goddess. The program consists of four primary phases. 1. Orbital missions, initiated with Chang'e 1 2007 and Chang'e 2 2010. These missions focused on mapping the lunar surface and gathering data about the Moon's environment. 2. Landing and rover deployment. Chang'e 3 2013 successfully landed on the Moon and deployed the U2 rover, while Chang'e 4 2019 made history by landing on the Moon's far side. 3 is sample return. This phase was realized with the successful launch of Chang'e 5, which aimed to return lunar samples for scientific analysis. For resource utilization and international collaboration, future missions, including Chang'e 6 and the proposed International Lunar Research Station, are set to explore the Moon's resources and enhance international cooperation. Before Chang'e 5, the last successful lunar sample return was conducted by the Soviet Union's Lunar 24 in 1976. As such, Chang'e 5 not only continues China's lunar legacy but also positions it among the few nations capable of conducting sample return missions. Mission Overview. Launch and Landing. Chang'e 5 was launched from the Wenchang spacecraft launch site on Hainan Island using a Long March 5 rocket. The spacecraft consisted of four key components: a service module, a lander, an ascent vehicle, and an Earth return capsule. After entering lunar orbit on November 28, 2020, the lander and ascent vehicle separated from the service module, descending to the Moon's surface. On December 1, 2020, Chang'e 5 successfully landed in Oceanus Procellarum, near Mons Rumker, a volcanic region characterized by young basaltic rocks. The landing site was carefully selected due to its geological significance, as it offered the opportunity to collect samples from relatively young lunar material, estimated to be around 2 billion years old. Sample collection and return. The lander utilized a mechanical scoop and a drill capable of reaching depths of up to 2 meters to collect approximately 1,731 grams 61.1 ounces of lunar soil and rock samples. This process was crucial for understanding the Moon's geological history and assessing its volcanic activity. On December 3, the ascent vehicle launched back into lunar orbit, or it successfully docked with the service module on December 5 to transfer the collected samples. The ascent vehicle was subsequently commanded to crash into the lunar surface to prevent space debris. The Earth return capsule then left lunar orbit, performing a skip reentry maneuver to safely descend through the atmosphere. It landed in Inner Mongolia on December 16, 2020, marking the successful conclusion of the mission. Scientific achievements and findings. The samples returned by Chang'e 5 are of significant scientific interest due to their relatively young age. Preliminary analyses revealed new lunar minerals and insights into the Moon's volcanic history. Notably, the samples provided critical data on the composition of the lunar surface, including the presence of hydroxyl molecules, suggesting water content in the lunar soil. This discovery is pivotal in understanding the Moon's potential for supporting future human exploration. Additionally, Chang'e 5's findings help fill a crucial gap in lunar chronology, allowing scientists to better calibrate models of the Moon's geological evolution and its relation to other celestial bodies in the solar system. Current status and extended mission. Following the successful return of lunar samples, Chang'e 5's service module embarked on an extended mission to the Sun-Earth L1 Lagrange point. This location is ideal for conducting solar observations and testing technologies for future lunar missions. In early 2022, the orbiter transitioned to a distant retrograde orbit around the Moon, facilitating further technological tests and preparations for subsequent missions. Future missions. The success of Chang'e 5 has laid a robust foundation for China's future lunar endeavors. The upcoming Chang'e 6 mission aims to retrieve samples from the lunar far side, further expanding our understanding of the Moon's geology. Additionally, China's long-term plans include crewed lunar missions in the 2030s and the establishment of the International Lunar Research Station, fostering international collaboration in space exploration. Conclusion. Chang'e 5 marks a pivotal moment in lunar exploration, showcasing China's growing capabilities in space technology and its commitment to advancing our understanding of the Moon. By returning samples from a previously unexplored region, the mission has provided valuable insights into lunar geology and has set the stage for future exploration efforts. As we look to the future, Chang'e 5's achievements will undoubtedly influence the trajectory of lunar research and international collaboration in space. Counterintuitive information in the context of China's Chang'e 5 mission. 1. Younger samples challenge established lunar chronology. While one might expect lunar samples retrieved from the Moon to be ancient, the Chang'e 5 mission returns samples that are approximately 2 billion years old. This is significantly younger than those collected during the Apollo missions, which range from 3.1 to 4.4 billion years old. This counterintuitive finding suggests that the Moon has undergone geological activity much more recently than previously thought, challenging established models of lunar history and evolution. 2. Limited operational timeframe. Chang'e 5 was designed to operate and collect samples within the lunar day, roughly 14 Earth days. The expectation is often that spacecraft can operate indefinitely, but due to the extreme temperatures faced during the lunar night, the lander ceased functioning shortly after the samples were collected. This operational limitation highlights the challenges of lunar exploration, contrasting with some assumptions about the longevity of such missions. 3. International collaboration in Chinese missions. Despite geopolitical tensions, the Chang'e 5 mission saw significant international collaboration, particularly with the European Space Agency (ESA), which provided tracking support. This collaboration is counterintuitive in the context of the often competitive nature of space exploration, illustrating that scientific endeavors can foster cooperation even among nations with differing political interests. 4. Scientific samples shared globally. Contrary to the perception that countries may hoard valuable scientific information, China announced that it would share the Chang'e 5 samples with international scientists. This openness is somewhat unexpected given the historical context of space missions, where nations have typically kept such resources closely guarded for national interests. 5. Skip reentry technique. The use of a skip reentry technique, where the spacecraft bounces off the atmosphere before descending to Earth, is not a common method seen in past lunar missions. This technique is counterintuitive as it deviates from the more straightforward direct re-entry methods, reflecting advanced engineering strategies that allow for safer landings. 6. Focus on volcanic regions. The choice of landing site near Mons Rumker, a relatively young volcanic area, was based on the assumption that such regions would yield valuable geological insights. This focus on volcanic terrains challenges the traditional view that older, more heavily cratered areas would be of greater scientific interest, indicating a shift in priorities for lunar exploration. 7. Technological testing in distant retrograde orbit (DRO). After completing its primary mission, the Chang'e 5 orbiter moved to a DRO for further testing. This step is counterintuitive because many would assume that after a successful mission, a spacecraft would return to a stable orbit around Earth. Instead, exploring a DRO signifies a progressive approach to mission design that seeks to validate technologies for future lunar missions. 8. Flag deployment as a symbol of soft power. The deployment of the first Chinese flag on the Moon can be seen as a soft power move, emphasizing China's capabilities in space exploration. This action might seem trivial compared to the scientific objectives of the mission, yet it serves a dual purpose of national pride and international visibility, making it a counterintuitive aspect of a primarily scientific mission. These points highlight unexpected facets of the Chang'e 5 mission, revealing how it not only contributes to lunar science but also challenges conventional wisdom regarding space exploration. The Chang'e 5 mission, launched by China's National Space Administration (CNSA) in November 2020, marked a significant milestone in lunar exploration and is pivotal for understanding the Moon's geological history. While much has been reported on the mission's success, several key aspects that many might overlook are critical for grasping its broader implications for lunar science and international space cooperation. The young age of lunar samples. One of the most significant yet often understated aspects of the Chang'e 5 mission is the age of the lunar samples it returned. The samples are estimated to be around 2 billion years old, making them the youngest lunar rocks retrieved to date. This contrasts sharply with samples from the Apollo missions, which range from about 3.1 to 4.4 billion years old. The relatively young age of these samples provides a unique window into the Moon's geological activity during a period when multicellular life was already evolving on Earth. This period is crucial for understanding the late-stage development of terrestrial planets and may give insights into volcanic processes that shaped not only the Moon but also other bodies in the solar system. Scientific instruments and their significance. Chang'e 5 was equipped with an array of scientific instruments, including a panoramic camera, a ground-penetrating radar, and a mineralogical spectrometer. While many reports highlight the mission's overall technological achievements, the specific capabilities of these instruments often receive less attention. For instance, the ground-penetrating radar allowed scientists to assess the subsurface structure of the Moon, which is vital for understanding its geological history and potential resources. The mineralogical spectrometer's ability to identify water content in lunar soil is another critical factor that could inform future lunar exploration and the potential for in-situ resource utilization for human missions. The location of the landing site. The choice of the landing site, near Mons Rumker in the Oceanus Procellarum, is noteworthy because it is an area characterized by some of the youngest basaltic surfaces on the Moon. This site had not been sampled by previous missions, making the samples collected by Chang'e 5 particularly valuable. The geological characteristics of this region, including its volcanic history, can provide insights into the Moon's thermal evolution and help scientists understand the processes that have shaped its surface over billions of years. The significance of this specific geological setting is sometimes overshadowed by the mission's success, but it is vital for advancing lunar science. International collaboration and open access to samples. Another critical aspect of Chang'e 5 that is often overlooked is the international collaboration and data sharing that followed the mission. The CNSA announced plans to share lunar samples with the global scientific community, emphasizing a spirit of cooperation in space exploration. This decision is particularly significant because it contrasts with the more nationalistic approaches seen in earlier space missions during the Cold War era. By making the samples available to international researchers, China is positioning itself as a key player in global space science and fostering collaborative efforts that could lead to greater advancements in our understanding of the Moon and beyond. Future implications for lunar exploration. The Chang'e 5 mission is not just a standalone achievement, it is part of a broader Chinese lunar exploration strategy that includes future missions like Chang'e 6, which aims to return samples from the far side of the Moon. This continuity of missions is crucial for establishing a comprehensive understanding of lunar geology, especially in regions that have not been previously explored. The mission's success also lays the groundwork for potential human exploration and the establishment of a lunar base in the coming decades. The vision for an international lunar research station, mentioned in various reports, suggests a long-term commitment to collaborative lunar exploration, which could involve multiple countries and agencies. The role of Chang'e 5 in technological advancement. The technological innovations developed for Chang'e 5, such as its ability to perform a skip re-entry maneuver, demonstrate China's growing capabilities in space technology. This maneuver, which involves bouncing off the atmosphere before landing, is crucial for safely returning samples from the Moon, given the higher velocities involved compared to low Earth orbit re-entries. The success of this technology not only enhances the safety and reliability of future lunar missions but also showcases China's advancements in aerospace engineering. Conclusion. In summary, while the Chang'e 5 mission has been widely reported as a significant achievement for China in lunar exploration, several critical elements are often overlooked. The implications of the young lunar samples, the advanced scientific instruments used, the strategic choice of landing site, international collaboration efforts, and future exploration plans all play integral roles in shaping our understanding of the Moon and its history. As China continues to advance its lunar exploration agenda, the Chang'e 5 mission stands as a pivotal point in both national and international space endeavors. 1. Scientific significance of lunar samples. The Chang'e 5 mission marks a pivotal moment in lunar exploration, as it returns samples that are approximately 2 billion years old, significantly younger than those obtained during the Apollo missions. This age is crucial for understanding the Moon's geological history and evolution, particularly during a period when multicellular life was emerging on Earth. The analysis of these samples can provide insights into lunar volcanism, regolith formation, and the Moon's thermal evolution, thereby filling critical gaps in our understanding of the Moon's timeline and its relationship with Earth and the Solar System. 2. Technological advancements in mission architecture. Chang'e 5 utilized a sophisticated architecture that mirrors the design of NASA's Apollo missions, comprising 4 main components: a service module, a lander, an ascent vehicle, and an Earth return module. The mission's successful execution of complex maneuvers, such as the skip re-entry technique used for safely returning the samples, showcases advancements in China's aerospace technology. This mission not only highlights China's growing capabilities in space exploration but also sets a foundation for future endeavors, including potential crewed missions and lunar bases. 3. International collaboration and scientific diplomacy. The Chang'e 5 mission exemplifies a model of international collaboration in space science. China's willingness to share lunar samples with global scientific communities, including researchers from the US, UK, Australia, and Sweden, is a significant step towards fostering cooperative scientific research. This approach not only enhances the understanding of lunar geology but also positions China as a key player in international space exploration, promoting scientific diplomacy through shared knowledge and resources. 4. Future missions and lunar exploration goals. The success of Chang'e 5 lays the groundwork for subsequent missions, including Chang'e 6, which aims to return samples from the Moon's far side. The long-term vision of China's lunar exploration program includes plans for in-situ resource utilization and the establishment of an international lunar research station. These future endeavors underscore China's ambition to lead in lunar exploration, with aspirations for crewed missions by the 2030s and potential collaborative projects with other countries, advancing humanity's presence on the Moon and beyond. 1. Luna 24 Soviet Union, 1976. The Luna 24 mission was the last successful Soviet lunar sample return mission. It landed on the Moon's Mare Crisium region and collected approximately 170 grams of lunar soil, which was then returned to Earth. This mission marked the end of an era of Soviet lunar exploration, similar to how Chang'e 5 represents a significant milestone for China. Luna 24 samples were crucial for understanding lunar geology and contributed to the scientific knowledge of the Moon's composition and history. 2. Apollo 17 USA, 1972. Apollo 17 was the final mission of NASA's Apollo program and is notable for being the last crewed mission to the Moon. The mission brought back 110.5 kilograms of lunar samples, including rocks and soil, from the Taurus-Littrow Valley. The scientific discoveries from Apollo 17, including insights into the Moon's volcanic activity and geological history, paralleled the objectives of Chang'e 5, which aims to enhance understanding of the Moon's evolution through the analysis of relatively young samples. 3. Surveyor 7 USA, 1968. Surveyor 7 was the last of the Surveyor program missions, designed for soft landings on the Moon to conduct scientific analysis. It provided valuable data about the lunar surface and helped to inform future crewed missions. The Surveyor program's focus on understanding the lunar environment and surface conditions parallels the scientific goals of Chang'e 5, which sought to explore the Moon's geology and assess the presence of water, thus contributing to the broader understanding of lunar resources for future exploration. Future outlook, predictions for China's Chang'e program. Summary of Chang'e 5 and its significance. The Chang'e 5 mission, launched on November 23, 2020, marked a historic achievement for China, representing the first lunar sample return mission since the Soviet Union's Luna 24 in 1976. By successfully collecting approximately 1,731 grams of lunar material, Chang'e 5 provided invaluable insights into the Moon's geological history, particularly the younger geological features around the Oceanus Procellarum region. The mission not only demonstrated China's growing capabilities in space exploration but also set the stage for future lunar missions. Immediate future, Chang'e 6 and beyond. Following the success of Chang'e 5, the next mission in the Chang'e program, Chang'e 6, is already underway. Scheduled for launch in early May 2024, Chang'e 6 aims to return samples from the Moon's far side, a region largely unexplored and rich in scientific value. This mission will further enhance our understanding of the Moon's geology and potentially provide insights into the early solar system. In the coming years, China plans to continue its lunar exploration with missions aimed at establishing a permanent human presence on the Moon. The anticipated Chang'e 7 mission, set to explore the lunar South Pole, will focus on locating and utilizing resources such as water ice, which is essential for sustained human exploration. Long-term goals, lunar base and international collaboration. By the late 2020s to early 2030s, China intends to develop a lunar research station, collaborating with international partners. This initiative is part of a broader vision to establish a permanent base on the Moon, similar to the International Space Station ISS, which would serve as a hub for scientific research and exploration. The station could facilitate long-duration human missions, allowing scientists to conduct experiments in the Moon's low-gravity environment. China's ambitions do not exist in a vacuum. Other nations, including the United States and members of the European Space Agency, are also planning lunar missions. This presents an opportunity for international collaboration, enabling joint missions that could share resources, knowledge, and technology, fostering a spirit of cooperation in space exploration. Technological advancements and innovations. Technological advancements will likely play a crucial role in the future of the Chang'e program. China is expected to focus on developing new technologies for lunar habitats, resource extraction, and sustainable living solutions on the Moon. Innovations in propulsion systems, life support systems, and habitat construction will be essential for the success of long-term lunar missions. Furthermore, as the Chang'e program progresses, we can anticipate the integration of artificial intelligence (AI) and robotics to enhance mission capabilities. Autonomous rovers and drones may be deployed for surface exploration, sample collection, and data analysis, increasing efficiency and safety for human explorers. Scientific research and discoveries. The samples returned by Chang'e 5 have already led to significant scientific discoveries, including the identification of new lunar minerals and insights into the Moon's volcanic history. As future missions return additional samples, we can expect a wealth of new knowledge regarding the Moon's formation, evolution, and the processes that have shaped its surface. Moreover, the study of lunar resources, particularly water ice, will be pivotal in understanding the potential for in-situ resource utilization (ISRU). The ability to extract and utilize resources from the Moon could revolutionize space exploration, enabling longer missions and reducing the need for supplies from Earth. Broader implications for space exploration. China's continued investment in lunar exploration is part of a larger trend in global space exploration, with many countries aiming to return to the Moon. This resurgence of lunar interest is driven by the Moon's potential as a stepping stone for future Mars missions and deep space exploration. The advancements made through the Chang'e program will not only benefit China's space ambitions but will also contribute to the global scientific community's understanding of the Moon and the broader solar system. By sharing data and collaborating on research, China can play a crucial role in shaping the future of space exploration. Conclusion. The future of China's Chang'e program is poised for remarkable achievements, with upcoming missions like Chang'e 6 and the establishment of a lunar research station. Through technological innovations, international collaboration, and continued scientific research, China aims to cement its position as a leader in space exploration. As we venture further into the cosmos, the knowledge gained from the Moon will undoubtedly guide humanity's next steps in exploring the solar system and beyond.